Alright, so this is going to go over doing basic statistics in Rcmdr. So the first thing that we need to do is we need to open up RStudio. And then under packages, we need to go down to Rcmdr. And click both Rcmdr and Rcmdr miscellaneous. And then we wait forever. And here we go. So the first thing that I want to do is I want to import data from a text file. Click on commas, and then I have put this on my desktop. We are using the personality.csv file that should be on Canvas under datasets. So you'd want to download it from Canvas, put it somewhere where you know you can find it, and then we've got it. So then I'm going to view data, and then we see that we have sex, age, salary, study level, mood disorder, body mass index, meditation, sport, music, extroversion, empathy. So these are ratings on some sort of a measure. So to get the descriptive statistics, I'm going to do numerical summaries, and let's do it on body mass index. And then I'm going to do this mean, and I want to do standard deviation and kurtosis. Click OK. And then we have our results down here. So we can see the mean was 22.14, the standard deviation was 3.9228, skewness was 2.46, kurtosis was 12. So we can already see that this stuff is not normal. So we're very skewed and we have a lot of kurtosis, and so we would need to do something with that indicator. So one thing that we could do with that indicator is manage variables in the data set. Standardize variables. So I want to standardize the BMI. And let's see if that did anything to our so I'm going to do the Z BMI and see if that changed anything, and it did not. So another thing that we can do is to make the log 10 transformation, which is going to change this into a log format. Essentially, it's not changing the distribution necessarily, it's standardizing it in a way that it changes it to a more normal distribution. And so what we would do is we go to data, manage variables in active data set, compute a new variable. I'm going to call it bmi.log, and then the expression that we compute is lowercase log 10, and we just type in the variable in parentheses, and we click OK. And then if I do statistics and summaries, numerical summaries, and we use that BMI log, and I click OK, we can see that our mean went to 1.33, where the mean is it used to be 22, I think. Standard deviation has changed, interquartile range has changed. The skewness, though, we can see has went to 1.29503. So let me go ahead and show you what it looked like before. And I just want to do BMI. We can see that we went from a skewness of 2.4 to a skewness of 1.2 and a kurtosis of 12 to a kurtosis of 3.4. So we transformed this in a way that has allowed us to get really close to a normal distribution. There are other ways of doing this. You can do square root, you can do other things. Unfortunately, this didn't get to where we would, this one did, but this one didn't get to where we could say that it has a normal distribution. But generally speaking, when we're working with these data sets and we have non-normal variables, we can do the log10 transformation. We can also do a square root transformation where we would, where'd my Rcmdr go? There it is. So if I did the same thing here, compute a new variable, I could do square root and then under summaries, I look under numerical summaries and I do that BMI log, and we can see that it changed our skewness and kurtosis. Also, the log 10 did a little bit better of a job, but still we're working with data that is non-normal, so we would end up having to use a test that was based on non-normal distributions, so a non-parametric test. But that's the way that we would, when we're just looking for mean, standard deviation, skewness, or kurtosis, and we're looking at those kinds of things, we're going to statistics, summaries, numerical summaries, and then we go ahead and select. We could select one more of these if we wanted to. Select OK, and it gives us those values. The transformation we would only do if we're seeing skewness and kurtosis that are violating that +2 and -2 in there. And that's that.